Hello, everyone. Welcome to our call, to our talk. Create detailed traffic models and simulations with open source tools and open data in the blink of an eye. My name is Martin Reuss. I'm from 7 Principles. I'm the product owner of Mobility Ops, the product we're going to present to you today. With me is...
Hi, my name is Robert Hilbrich. I'm team lead at the German Aerospace Center in Berlin. I'm also one of the 2 project leads of the EclipseSumo project. And I'm also the CEO of our spin-off company that we'll get into play later on.
Okay, first of all, my English is very bad and my presentation skills are worse. But we get it done, okay? So this is, to get into it, this is a project we made several months ago for the city of Munich. They wanted to decrease the traffic by delivery vans, and they implemented in the city of Munich an urban micro hub. So they are delivering the parcels to this hub, and they want to deliver from there to the households using cargo bikes. Yeah, and the problem here is the authorities have several problems in Germany. So they have a lot of traffic in the city, a lot of individual car traffic. They have to do the mobility change, in German the Verkehrswende, to reduce CO2 and to get more public transport, the people to use more public transport. And the discussion about the public space. Who owns the public space? Is it parking areas? Should it be given back to the community? And the stakeholders are also not that easy to handle. They got the citizens of the city, of course, then laws, also the politics is a key player here, and also initiatives from citizens to get it started. So the question was, in that case, what are potential traffic and emission impacts of establishing micro-hubs and cargo bikes for last mile delivery? If you go more in specific, it's what happens if I do something to my traffic. These are the challenges, the traffic, the responsible persons for the traffic planning are dealing with is the complexity. It's very complex to make a traffic model or to plan something around it. You have a lot of manual effort to do this. You have to know what you're doing. You have you need the knowledge to do that. And the solutions that are actually on the market are very expensive. The second point is it's like everywhere. There's a shortage of skilled workers. The cities don't get the people needed to do the job. And also you have to know your tools you're using. And of course the costs and the access to data necessary to build up a model is very high. And you have to do several steps. You have to generate the model. You have to do the simulation, and of course you have to evaluate it, and you have to analyze the data getting back. It's very high costs. So the question is, are there any open source simulation tools in the market to solve the problem? This is where Robert comes in.
This is my cue. So thank you very, very much. I guess I need to...
Yeah.
Thank you. And of course, as most of you basically probably know me by now, there is, of course, open source traffic simulations in the market, even as part of the Eclipse Foundation ecosystem. So who of you guys heard about Sumo before? Who of you guys used Sumo before? Okay. So the idea is really, Sumo is a tool that makes it easy for you to build a digital twin of a city. So you can really try to simulate the movements of almost all moving objects in a city. Bicycles, pedestrians, of course vehicles, trains, trams, even ships and trains. So it really gives you a very nice overview of what's happening in your city, making Sumo a very versatile tool for a variety of research questions or urban planning, for instance. And yeah, it is pretty old. So we've been developing it for the last 20 years, or more than 20 years actually. So there's a lot of functionality in there to really get you started quickly. How does it look like? Can you start a video? Just to give you a quick impression of how does a Sumo simulation actually look like. It gives you this kind of bird-eye view of a city, and we will slowly zoom in, and you can see all those vehicles that move in the city of Braunschweig here. You can see, as we zoom in, you can see how they cross these different junctions. You can see that we are really running this as an intermodal simulation. There were some trains on the lower right. And it is all being simulated not on a high-performance computing cluster, but on a regular laptop. So it's really efficiently programmed, or it runs in a very efficient manner. So it's really, really nice. You can really work with your city and analyze the research questions that Martin just described. The interesting thing is, Sumo is still an application that you will download or that you will compile for yourself if you like. For cities, this is not always an option. So we started a spin-off company from the German Aerospace Center to actually make it a little bit more easy. Because we wanted to make sure that more people are able to tap the potential of these simulation tools by providing it as a cloud service. We call this SESAM, a simulation environment for seamless automated mobility. And it is reachable on this URL. So right now you can flip out all your smartphones. You can check it out there. You can build your scenarios there. You can run simulations there. You can download all the simulation results. And the really cool thing is that we also provide a REST API, a RESTful API that makes it very easy to integrate Sumo and the simulation capabilities into your workflows. So you can, with a simple shell script, you can spin it up, you can create scenarios, you can run them, you can download simulation outputs afterwards, and you can use them as you like. So check it out. I think it's pretty nifty and pretty cool. When we look at such a Sumo simulation, when you look at a Sumo scenario that you are using there, then usually it's comprised of a variety of ingredients that you use. And you can cluster them in, for instance, road networks that you usually need, right? Of course, there's some road network that you need. Of course, you need some form of infrastructure, traffic lights. You need rules that govern your traffic. Who yields to whom, for instance. And finally, you need a traffic demand. Demand saying who wants to go from where to where at which point in time. So basically, where do people want to go? Interestingly, though, the first two, they basically can be derived from OpenStreetMap with added heuristics in Sumo. So you can really do a lot there with OpenStreetMap. Unfortunately, for the traffic demand, there's no real open source combined easily to tap into data source. There are some Sumo scenarios available, of course, but if there's any area that you're looking at, you're most likely missing a precise traffic model, a precise demand model. This is a cue for you.
Yep, thanks. This one? Thanks. Okay, so this is where mobility ops comes in. To create the demand generation, we also use another tool from the DLR, the German Aerospace Center. And we gather all this data, and I think we should take a look at this data. So I have a little hands-on. We take a look at QGIS to give you an impression which data we are getting. So we also use OpenStreetMap, of course, to get the net. We see here the lovely city of Leonberg near Stuttgart here around. And first of all, we want to know where the people live. So we are extracting from our database the households. Where do they live, actually? Because this is the start of all traffic for local people. Then we want to know points of interest. So we extracted from OpenStreetMap 4,400 points of interest, but not all are interesting for us. So the shops is one activity everyone does. People are moving to a store to buy something, to daily goods or shoes or something. And also, it's interesting where people work. So we're extracting also that from OpenStreetMap. And with that and behavioral data, we can now say a person, and I got one example here. This person lives here in Gebersheim and works here, probably goes shopping here and goes back home. So this is the basis. It's the activity chain of every person living in the city, and this is the basement for all movement. And we have also the modal split. We know which mode does the person use. Is he using a car, a bike? Does he take the bus? And yeah, bus is a good point. We also use this general transport feed specification data to get all the data for the public transport. And this is one trip for a person, and these are all trips for persons. So it's 218,000 per day we generated using tools in the data. Why are so many starting here and here? So these are the commuters from outside entering the data model. Yeah, you can't see anything because it's too much. But all this data, I hope the impression worked. We give back to Sumo. Sorry. I'm skipping forward. So these were the data we are getting or we are using for our model generator to generate the model. There are several more databases we are actually using. We give it to Tobias, and then we put it to Sumo to make the simulation. All the trips we calculated for one day. And then the trips are simulated in Sumo, and yeah, we got here the results. We are also getting it in mobility ops. We want to develop a reporting engine to make standardized reports for everyone, using Jasper reports or something like that. And we also use this visualization engine, a GIS system. Today it's QGIS because it's open source and really powerful. And we also want to make a scenario editor, so you can define the thing you want to evaluate. So to delete a connection or to to change the max speed on a road, for example. And this is why this box should be blue and red, because this is the sum, or we both are in this scenario editor. We saw that when Robert described the sesam, it's the same thing. So we are working on that. If you have any questions, I forgot, please give me a sign. So we developed the prototype from 7P with a really small bunch of people, and for 2 to 3 years now. And we have our prototype ready, and we say it's possible to make traffic models using open data, and the model generation can be completely automized. It's not 100% today because of the validation process. We did not include that today, but still working on it. And the time and effort needed to reduce to a couple of days. So this is quite good. We have it all in Docker and automized. So in a couple of days, the system is running and is up. So this works fantastic. Coming back to our example here. I don't know actually. Yeah, no. To wrap it up, local authorities struggle today with data and evidence-based decisions in designing the urban mobility today. There are open source tools and open data available that are suited for solving the problem. There are some parts missing. The automated generation of a precise traffic model, so mobility ops fits in. And with a well-formed community around our current prototype, we think it would fill in the gap and have this tool chain from start to the end, full automated. So we joined the Open Mobility to discuss these points. Robert is the moderator of this interest group, Eclipse interest group. So if you're interested in these things, please join. We are planning as 7P to start an Eclipse project we're thinking about with mobility ops to get into the community. So this is also the cause we are here today. And we made 2 webinars. Maybe you would like to take a look at it's effiziente Zustellbezirke, it's these delivery districts. Actually, they are in German. But maybe you have to want to take a look. And also we got a webinar we made reducing max speed from 50 to 30 and which are the effects taking place. So that's it.
Thank you. Maybe I can maybe we buried the lead a little bit. The key point here to take away is that thanks to the work of 7P, we are now looking to, or we have plans to open source mobility ops to become a new Eclipse project. So basically, for those of you who heard my talk on Monday in the community day, I basically stated that in addition to those simulators that we have readily available, we need more tools to provide data for building digital twins. And we hope that with mobility ops being part of the Eclipse ecosystem, we can have the ability to actually build these kinds of data. So we are more than inviting you to take a look at this project, to use it in your project, and maybe even build on it, extend it. This is what we are actually aiming for here. Thank you. Are there any questions? Yes, Moritz?
Yeah, so you talked about validating the generated demand model. How did you or how would you go about doing that? Because I think you had on your one slide you want evidence-based, whatever arguments for these city governments, and I think the validation point is very important for the government.
Yeah, it's really important and not easy to handle this because you need the actual data. So when you go to a city, they say, yes, we made a calculation of the traffic, but it's 2 years ago. And so the problem for us is to get the actual data. So big cities do have actual data, also in the MDM or Mobilität in Germany. But smaller cities, it's really a problem. So we are going have to get a middle path, I think. And actually you got also the data for 1 road or 2 roads or 10 roads. In Munich, it is, I don't know how much traffic counters they have, maybe 50, I don't know exactly.
When you're talking about data, but just now you talk about traffic counts.
Yeah, we are always looking for the how is it called? Tagesganglinie. I don't know of English. So this is the pot we are aiming at, but it's not always there. And then we calculate the GEH value and the SQV to get it precisely.
I mean, and to be honest, of course, validation is a problem. Calibration is always tricky. But when you talk to smaller cities and try to get a feel of, let's say, the data that they are currently working with and the Excel sheets that they're currently working with, let's say this is not fully validated, but it's a significant step towards a more evidence-based decision that is happening. Maybe not for the bigger cities, but for the majority of smaller cities with 50 to 100,000 inhabitants. This is, I think, a significant improvement over the current state of art, I think. Thank you, though. Any more questions? Anyone checked out Sumo in the cloud in the meantime? No one? You did? Cool.
So how strong is that API you can use? Are you actually able to use Sumo full-fledged and do everything you could do with XML files?
There's a documentation there. The API is more coarse-grained to start a simulation, to create a simulation with these kind of parameters. If you run the simulation, you're basically more like you can configure what kinds of outputs you want to get, and you get notified when they are available. We were thinking about supporting protocols like DCP to really support a distributed simulation where you can basically have the algorithm for controlling an ego vehicle running on your machine being connected via TCP/IP to the simulation running in Sesam. But that's a long road ahead, and I'm not sure if the performance and the transport capabilities are actually there. Oh, Michael.
Yeah, I also have a question. So what is your estimation? How far will we get when we don't get any data? So if we only use OpenStreetMap and the city has nothing, can you still do something with that?
Yes, of course. Because of the power of Sumo, it's not the identical digital twin then, but it's better than guessing, I think. You have, if you change things, you define your scenarios, you get the right direction or die Bestätigung, das zu tun. So if we talk to traffic planners, they say, I want to check out different things. What happens if I add a lane to get a left turn? And what happens if I skip this line and only make left turns possible the next crossing? So this is the power, I think, of the mobility ops to generate the demand out of nothing, so to say, if you don't have the data, and the power of Sumo to make these happening and to compare the scenarios and say, this happens then, and I should go this way, without making a questionnaire or to make a test environment setting up. It's less costs. And you have the ability to play around. Yeah.
For your API approach, do you plan on supporting like sending events to like a broker, like a QTT, whatever, for the whole thing? Because yeah, it would be nice. Usually, data comes in reality.
Are you talking about this one here, or are you rather talking about this one here?
The SESAM level. So, for example, I would set up a simulation there running in the cloud, and I want to react to things happening there because I want to test what I would usually do real data I would get from traffic cameras or stuff like that. So, something like this possible.
Interesting. I think there's no technical limitation to actually do that. But on the other hand, there's currently no customer demand that we've faced to actually ask for that. But there's no reason why this couldn't be possible. Absolutely.
Yeah, this would be quite interesting. For example, in our case, our city started to install a bunch of traffic cameras, which we look where people are, where cars are driving, and stuff like that. And then the usual thing will be done with that to try to predict accidents and try to control a little bit the traffic flow and stuff like that. And it would be nice if we could, then we have the real data, but in order to test some models for the collision detection or whatever, it's also nice to have some things like simply simulated for parts where we don't have camera data for now.
Mm-hmm.
And with such a mechanism, we could say, okay, just simulate this part because the traffic I've used it in Sumo out of the box by just using the OpenStreet data, generated a traffic model, and you had exactly the same choke points for the traffic we have in reality without any modification to whatever it does there. So this was great. But then we could use it without having a Sumo running ourselves, but just say, hey, we have our simulation running there, and then we plug in the simulated data, and then later we can exchange this by, we have now the real traffic camera data or stuff like that.
This is really, really good, because this was exactly kind of the reason why we tried to have a presentation here, because we wanted to show that these kinds of architectures are absolutely possible with open source software. We would like to talk to cities and see what their requirements and their possible use cases, just as you just described now, what their use cases are and how we can make these projects fit to work well with these kinds of use cases. So there's absolutely flexibility. This is not a closed project. This is a beginning, and that's why we are asking here to get feedback where you see fit for these kinds of features. Absolutely, thank you. Pleasure. Any more questions? Is there any part where we can shed some more light on? All right, then I think everybody well deserved some coffee. Thank you for being here, and hope to see you soon.
Thank you.